طيب السلام عليكم ورحمة الله وبركاته. بسم الله الرحمن الرحيم. So this is the new topic, new session, and by this we are done, or inshallah we will be done with the core part of the course, the basic information that you need to know about IR will be inshallah done by this lecture. So can you remind me of what the topics that we covered so far? I know that I ask you every time, but just to make sure that you remember. We didn't cover anything? Retrieval models, okay. Yes. Evaluation, seems like you like evaluation very much. Okay, your favorite topic. Ranked retrieval, yes. So ranked retrieval, evaluation, what else? Ahlam?
Manual function.
Manual?
Weighting function.
Weighted, term weighting functions, it's related to ranked retrieval anyway. Okay, so that's the same topic. What else? Building test collection is part of evaluation. Okay. Yes. Language models. Okay, so part of ranked retrieval. So in ranked retrieval, we discussed actually two main paths or main directions: vector space models and language models. Of course, there are other retrieval models. What else other than that? Yes. Query expansion. Okay. And in the beginning, what did we cover? Relevance feedback is part of the query. Yes. I mean not in the beginning of this last session, the beginning of the course. Boolean retrieval and indexing. Okay. So if you go back now, you will see that we covered like 6 or 7 topics already. These are the core topics in IR. And I wouldn't imagine that any IR course, I can say it in the world probably, doesn't cover any of these basic basic topics. Okay, but then the advanced topics, the topics that are built on top of that might vary across different courses, but these are the core topics in any IR course. But one is left still that inshallah we'll cover today, which is preprocessing. Where is preprocessing in our pipeline? Remember, we do indexing offline, okay, and the rest is done mostly, or most of the time, most of it is done online, right? But still, there is a step that is that will be done, as you'll see, will be done both online and offline, which is preprocessing. This is actually the first step that is done, and after that, we do all the other steps that we discussed. So just to remind you of where we are, this is the basic indexing pipeline. So we said that we have something called tokenization, which is splitting whatever document, let's say that we are talking about indexing here. So we will split the document into words, okay, or we call them tokens. And then we do some normalization, we'll discuss that inshallah today, to convert these tokens into what we call terms. These are the terms that will appear in the index. And then we do indexing after that. So we discussed indexing earlier, but we didn't talk much about tokenization and normalization. And these are the two steps that we call preprocessing. Okay? We call it preprocessing because we have to do it first before we index, and then before, of course, we do any search. So this is the main topic today. As I said, preprocessing is done at both sides, online and offline. Offline is done to what? To the collection, to the documents. Okay, so it's done to the documents, and online it is done to the queries. And it has to be done in the same way so that we can match them. Okay, so the same way that by which we get the terms from documents, we have to apply it to get the terms from queries, the given query, so that we can match them. So here, this what we call text transformation from what we see in the document to what is actually indexed and will be matched against the query is the pre-processing stage. So we do that, of course, to better match between different forms of words.
So, Doctor?
Yes, Muhammad.
Is this the stage where we remove these words? I keep forgetting what they have a specific term, like for
Stop
example,
words.
yes.
Yes, we'll do that today. Yes, we'll cover that today. Did I answer your question?
Yes, thank you.
Okay. Okay, now the preprocessing pipeline has 3 steps. First, tokenization, then stopping that Muhammad was just discussing. Okay, sometimes we call it stop word removal or stopping, and the third is called stemming. So let's go through one by one. The objective for preprocessing is to identify the optimal form of the term to be indexed, or the terms actually, to be indexed to achieve the best retrieval performance. As you will see after today's lecture, it's not effective, or at least it's not the most effective way, is to index the words as they are. We have to do some transformation, some pre-processing to the words that appear in the documents and the query so that they will better match. They will match more effectively. So that's the objective of pre-processing. Now we said that we have 3 steps, right? Tokenization, stopping, and stemming. But actually there is one step before that, but we assume always that it is done automatically. Okay, we don't do much about it, but it is there. Okay, what is this? We are given a document and we need to read it, right? Actually, the machine needs to read it. The documents are written as bytes, right? On disk. Right? But of course, there is some encoding by which we translate these bytes into, no, not words. Do we get words immediately? Characters. Okay, characters. And the characters will, of course, constitute the words. But there is a process that converts or translates from the byte sequence to the character sequence. This is called encoding. Thank you. Okay, so we need to know, the first thing we need to know is what encoding is used in writing these documents. There are many encoding methods. Okay, but usually we don't care about that because we assume that the documents, or we know from some metadata that the documents are encoded this way, like UTF-8, UTF-16, ASCII. These are all different encodings, right? And we have to know this in advance so that we can translate the byte sequence in the documents into meaningful characters to us, to humans. Okay? Another thing, what format? Is it just text, PDF, Excel, HTML? All of this has to be considered, right? Because the program that will read the PDF document or parse the PDF document is different from just parsing text, right? So we'll assume also that we know that in advance. Another thing that which is very important also is the language. Okay, and this is actually a problem, a classification. Actually, each of these is a classification problem by itself. Okay, but we tend to overlook these problems in IR. The language, most probably we assume that we know that in advance that this is an Arabic collection or this is an English collection, but sometimes we need to detect automatically what is the language of the document. So that's actually a classification problem, language detection. Okay. So often in IR we do that heuristically, or this information is given to us. Another question, before even tokenization, we didn't talk about actual preprocessing here, is what is the unit document that we want to index? And I think we kind of discussed that earlier. Is it a file? Each document is in a file? Or is it an email? And if we are indexing the email, are we indexing the quoted part of the email? Are we indexing the entire thread of the emails? When we index the email, are we indexing the attachment to the email with it? So the question of what is the unit of indexing that we need to use in our system is a big question, is a very important question. Now this question, the answer to this question depends on the problem, depends on what the user will search for. So you need to understand the domain of the problem so that you can decide what is the unit that you will index. For example, if we are talking about books, as we see in the slide here, is it every chapter will be a document? Or every page, or every paragraph, or every sentence? Depends on what? Depends on what the user actually wants. If the user will search for books and he wants entire book, then maybe a book will be the document. If you need to present to the user specific paragraphs within the book, then you should think of indexing every paragraph as a separate document, right? So we tend to use the word document in IR in a generic way, okay? But you need to think what a document actually is. That's a question that you need to answer before we do any pre-processing. And by the way, in this lecture, we will see, or you will hear me raising much more questions than giving you answers to these questions. We'll see that we have many questions that we need to think about, but there are no golden answers to these questions. Okay? Of course, sometimes we give hints on how we can answer these questions, but many of them, maybe not the ones that are on this slide, but later in this lecture, many of them needs experimentation to really decide whether we should do this or that or that. Okay. So you need to understand the collection that you are searching, you need to understand the user behavior, you need to understand the user needs. Okay. Now we'll switch to the first step, which is tokenization. So before that, it was step 0. Okay. We overlook this step usually in IR, and we start with tokenization. Type. What is tokenization? Tokenization in brief is converting from the sentence or text in general to what we call tokens. Okay? And the tokens, you can think of them at that stage as words. Okay? So the question here is how to split the entire string of the text into words. Okay? So for example, if I have this input, friends, comma, romance, and countrymen, then what are the tokens here? Friends, romance, and countrymen. But how about this comma? First, how did we split? How did we know that these are the words or the tokens? That's the most commonly used heuristic, right? Split in spaces. But how about commas? We can also split at commas, right? How about dots?
Doctor?
Yes, Muhammad?
I thought the whole reason we use bag of words is that we should keep commas to keep context around, no?
Why do you think there is the commas will add to the context?
I mean, a lot of times, like for example, a full stop or a comma would define to give some idea of like the definition between words. I think there was an example.
Let me expand on this idea, Muhammad, or expand on this question. Here in this example, I said friends without comma, right? Let's assume that we added the comma to friends. So now friends has comma. What is the effect of that in what we studied so far in the course? What is the effect of that? Yes. It will not match friends. It will not match friends. Whenever the query has friends, friends is not there in the, at least assuming that this is the only document. All documents will be like that. Friends is not there, and friends comma is there. So now this is the term that will be indexed. And remember that we always match the query terms with the index terms, with the terms that are in the index. If the term is not in the index, then we'll not be able to use any information, right? We'll not be able to score this. Huh? Okay, let me say here something very important. Bag of words is just one model. It can be, by the way, bag of bigrams. It can be bag of trigrams. Okay? It can be any other models. So bag of words is not the only model that is used in IR. And you saw that sometimes we need the positions, right? Earlier in the course, we stored the positions because there are phrase queries that we need also to deal with. Okay? So bag of words is not the only thing. But my point here is that if we add this comma, then this will be different term than friends, and that will make mismatches if we have the friends in the query. Okay, is that clear? With us, Toba? Okay. Right. Now we said that we will split the whatever text we have. By the way, it doesn't have to be sentence, but this is just an example. The text that we have, we split into tokens. What do you mean by token? Token is just an instance of a sequence of characters. So this is a token, of course, without now the comma. So this is one token. That's another token. That's another token. That's a fourth token. Now, if the word has another friends here, let's say that we have space here, and then the word friends again. How many tokens we can get from this? 4? Huh? 5. 5 or 4? Huh? 5. This is a token by itself. It doesn't mean that it is repeated that it's different token. It's not a token. Okay? Tokens are, that's why we call it instances. Tokens might be repeated, of course, right? Later we will count how many times it appeared, but as tokens, as a token stream, these are different tokens. They happen to have the same sequence of characters, but they are different tokens. They are different instances. Okay? Right. Now each token is a candidate for an index entry. When we what we will index, actually we will call eventually a term, but that's not still the tokens. Okay, so that after more preprocessing we'll call it a term. Now we said that we will split on spaces, right? What else? Maybe commas, maybe dot. Okay, new lines. Okay, so there are some of these characters that we can split on. Okay. Now the question is, what are valid tokens to emit? And we kind of started to think about that, right? Commas, I think they should not be attached to words. Okay. We will discuss this question right now. Okay. So let's talk about issues in tokenization. So it seems so far that tokenization is really straightforward. If we have these splitting characters, new line, dot, comma, semicolon, right? Space, we just split based on this and we get the tokens, right? Very straightforward. But there are many issues. For example, how about this one? Finland's capital. Should we split on the apostrophe? So we should have Finland only, or maybe Finland with apostrophe S, or Finland's without the apostrophe? It's not clear, right? Not very straightforward now. Why is that? If we split on that character, we lost some of the context. Okay? We lost some of the context. We want to say that this is something related to Finland. Okay? If we just remove that, then this is lost. Okay? So that's a question. Another thing, something like this, Hewlett Packard or HP. Is it one token or two? If we split on the hyphen, then it will be two tokens. But actually, this is just one concept, right? So, not very clear if we should break it into two tokens or not. Something like state of the art. Yes, these are different words, but this is as by itself is one terminology at least, right? So it's not very straightforward how we can actually do the tokenization, although it seems like very simple, but there are many cases that you need to think about. Even with sequence of characters that look like one word, you might think of breaking it into multiple tokens, something like lowercase. Okay, is it just really one token or actually two tokens? Maybe some people will write it as one word, others will write it into two words. Remember always that why we think about these issues, because eventually the goal of this preprocessing is trying to match different forms of words in the documents and the query together. Okay? Because this matching is a must. If I want to match a document to a query, they have to match on terms. Okay? So we have to convert the words or the tokens in the documents and the query into a form that can match. Okay? So if some documents have lowercase as one thing and others have lowercase as two tokens, then when the user will write one of them, it will match one but not the other, unless we deal with this. Okay? About this, San Francisco, New York, or River Nile. If you split on space, and even the space has an issue now, okay? If you split on spaces here, what happens? What happens? San is a word and Francisco is a word. Yeah, maybe more clear when we say New York. Okay, New is actually a word by itself if it's isolated, right? And York actually there are cities called York by itself also. So if you do this, then you are not indexing concept of New York. It's completely two different concepts, two different terms. Okay, so that's a question. Yes, Muhammad.
So I'm curious, Doctor, does that mean that tokenization should be aware of the indexing and the retrieval models, or should it be
Did we do indexing yet?
But
no, we are doing that.
For example,
we are doing that before indexing. We are doing that to index, to find out what we will index actually.
Because that's what I'm curious about. Because like if we have an idea of how we're planning on indexing, then we can prepare ahead in terms of like how to tokenize, no?
Are you saying that you can learn something from the indexing, but indexing is based on that, Muhammad? I think what you mean is that we can make some processing of the collection, or might use some processing of the collection to make decisions like that. Like for example, here, how can we decide if this is actually one token or two tokens? Think of what we studied so far in the course. Is there a way, using the ideas that we discussed, How can we know that these two words actually are related together? Co-occurrence. Actually, co-occurrence in subsequence. Okay, it's like phrase. Yes. How many times this phrase? But we will not know that it's a phrase unless we know the co-occurrence of these two words. Okay, so something like the association measures that we discussed today and last week can be used to determine these. These are called phrases. Okay, and that needs analysis of or reading the entire collection, even before doing indexing, just to know this kind of terms. How can we know that San Francisco is just one thing, not two? Yani by your knowledge, by the knowledge. Just check, and it's. But how? What do you mean by just check?
I go to San Francisco and go to my dictionary, for example, if I have a check there. Yes.
Marina, okay. You said I will go to San Francisco because you know that San Francisco is a special case, right? But the machine doesn't know that in advance.
So it takes two. I take two words.
Any two words.
Any two words.
This is what we are saying, that you need to go through the collection to check this, to detect something like these words. Okay? To do that, you have to go through the entire collection. Unless you have that linguistic knowledge. But the problem with the linguistic knowledge that gives you a list of things that will never end. Because every time we get new things like that. Okay? It's not a fixed list. And if you do it for one language, you might not find it for other language. Okay? So you have to think of ideas that are automated to capture something like that. Okay? Now, if we split on this space between San and Francisco, or between New and York, what will happen is that if the query has New York, it will match any document that has New but not York, right? Not York. That's the problem. Or document that has New and York, but they are not next to each other, right? If we are using bag of words will destroy the positions, right? So it will match. A document that has New and York far from each other, it's like building new university in New York City. It can happen, right? And that will match New York. But that's not relevant. Numbers. How about numbers? What should we do with numbers? Why numbers are important, by the way? Maybe you should get rid of numbers. Yes. Yes, there are many numbers that are important, right? Why do you think that these numbers are important? How did we get the idea that these are important? It's not changing the result because people search for this, right? I think you have a very good example in programming, right? Usually we take the code for what? For errors, and search by that code, right? Imagine that Google doesn't index these codes. How your lives will be? Okay? So there are numbers, of course, that are very common in queries. And if they are common in queries, then the search engine should support them. Right? So like the dates, like course codes, telephone numbers. Okay? So that you can think of many other examples. And how you would tokenize this, even if you will keep them and you know that numbers, but of course not all numbers, by the way, but let's say that we talk about all numbers here. How we will tokenize it? How do will we take it as it is? Or, for example, we will say that 3 is a token, 20 is another token, 91 is another token. How would you deal with that? Is it just one token or different? So there are special cases like this that you have to think about if you want to be very effective. So doesn't seem that the idea of splitting on spaces blindly a good idea, right? Okay, you'll be amazed. Fine. URLs. Should we tokenize it or should we keep it as it is? Usually we keep the domain as one token, right? And maybe the entire thing as another token. So you need also to think about that. Social media, hashtags and mentions, retweets. So a hashtag like this, Black Lives Matter. What are the tokens that we will get from this? Okay, 3 tokens, 1 token. Okay. 3 tokens because you thought that we need to split on underscores, right? But if you split on underscores, what will happen? You destroyed the hashtag actually. There's no hashtag, خلاص. Hashtag is gone. Okay. And even if you keep it with the underscores, as I think Hawla is hinting, there are many questions. Should you keep the hash sign or not? Should you remove the underscores and bring them all together as one token so that you can match something like this one? So in preprocessing is not straightforward. There are so many. Yes, Muhammad?
We are like, it's safe to say that tokenization is context aware.
Yes, for sure. The proper tokenization should be context aware. That's a great sentence. Yes, I agree with you. But it's not easy. That's the main problem. It's not easy to be aware of everything. So you have to make decisions. As a designer of the search engine, you have to make decisions based on the domain of search that you are working on. Decisions in social media probably might be different, completely different than web pages or emails or books or medical documents. Right? All of these are different types of documents. You need to think about how to do the tokenization in each, probably differently. Language-dependent issues. So far, we didn't talk about language, right? Okay. Now let's talk about language-dependent issues. French. How about this one? Is it 1 token or not? Or 2? 1? 2? Should we convert it to the expanded version? Or should it match? Should this match with this? I told you I will raise questions more than answers. Okay? But how can we answer some of these questions? How can we know which one is better? With experiments. We have a test collection. We try with this, we try with that, and see which one will be effective. In German, noun compounds are not segmented. So this is 1 word in German, by the way. This whole thing. This is 1 word, our life. So the meaning of this is, I don't know, anyone knows German here? Okay, so this is life insurance company employee. By the way, we have in Arabic something like this also, right? In Arabic, you know that there are words that can be translated in English in 3 or 4 words, right? But it's not that long, and it's even more compact, okay? With some of the characters, only adding some of the characters will add English words, or maybe 2 words. Here it's a different story. Here we have one really long word that is translated to multiple words. So we might need to do what we call segmentation here. So we need to, of course, because this is a compound word, you have to actually deal with it for search. You will have to do splitting. You have to do segmentation. You have to make sure to detect that these are different words and split them. And based on some experiments, that gave 15% performance boost if you do that properly. Chinese and Japanese have no spaces between words, aslan. Okay? I don't know what the meaning of this sentence is actually. Anyone here knows Chinese or Japanese? So that's even a bigger problem now. There's no spaces, aslan. Okay? The spaces that we think that it's straightforward, just split on spaces and inshallah will work. It will not work here. It will give you the entire document as one token if you do splitting on spaces. So you have to do segmentation. You have to detect the smaller units of the language. And then, of course, index these units. Okay, with all of these issues, there are some common practices, of course. Okay? So what do we do in common practice? Split at non-letter characters, like commas, semicolons, dots. By the way, dots, do you think there are problems with dots? Like what? Emails, okay. What else? Decimal numbers. Okay. Things like Dr. X. Okay. You might need not to split Dr. and X. You might need to use both and so on. So the common practice is to split at non-letter characters, and you can add special cases if required to this. Yeah, for example, if the dot, maybe you can detect that some of the dots doesn't split actually sentences, like when the dot appears in a domain name or in a number or in an email, then you should not split, things like that. You can add these special cases. Some applications have special setup, like in social media. You cannot just split on every non-letter because there are things that have meanings, okay, like the hashtags, like the mentioning. URLs are special cases. Protein and disease names. Okay, so some applications need some special care. Okay, we are done with tokenization. Any questions? Many issues, right? Doesn't seem to be straightforward, but there are common practices that are easy to do. Did you look at what is happening in your code? There is tokenization that's happening, by the way. Look at it. Don't change it, okay? but look at it. Okay, the second step, which is quite straightforward, is called stop word removal. So what is this? If I have this sentence, this is a very exciting lecture on the technologies of text. Are all of these words really important to know what this sentence is about? So what are the words that are not important here? Huh? This is
Very exciting.
a, on, the, of. All of these are called stop words. Okay, are just removed. Most probably. Okay, so something like this. Even very. Sometimes. Muhammad, did you want to say something?
I was curious why we kept exciting, since it doesn't contribute anything to the sentence.
Exciting is not a standard stop word, of course, and it will distinguish between boring lectures and exciting lectures. So I think it is important here in the sentence. But generally, exciting is not among the standard stop words. There are standard stop words for each language. Exciting is, I don't think, is one of them, because it has a meaning here. If you removed it, the meaning changes a bit. Okay. So stop words are the most common words in the collection. Like these, the, a, is, he, she, I, him, and all of this long list. The idea here is that they have little contribution to the semantics, little contribution to the meaning of the sentence. If that's the case, why do we have them أصلا in the language? If you agree with me that they have little semantic meaning and actually will remove them, why do we have them in the language? Yes?
Understand, like, if we remove them, we only understand the topic,
Yes.
but not the actual meaning.
They contribute to what? They contribute to the structure of the sentence, right? And we understand the structure of the sentence. If I give you just random, yes, you will know something about what the sentence wants to know, and we did that exercise earlier, right? But you might not know exactly the meaning of this specific sentence. Okay? In RR, we care more about the topic, the general topic of the text, not to the exact meaning of every sentence. Okay? And they appear a lot, of course. 30 or 40% of the English text has these words. Can you imagine 30 or 40% are just tokens that are added just to maintain the structure of the words. Of course, there are special cases, and as you will see, sometimes the meaning depends on these words, sometimes, but most of the time it doesn't. Over time, we see new stop words. For example, in tweets, if you look at tweets, you see RT, right? Like a tweet. Many tweets, right, are being retweeted, and when you see the text, you see that there's RT at the beginning. This is like now a stop word, right? Because the fact that this is a retweet is also in the metadata of the tweet, so you will not lose it if you remove the RT. So it has an influence on the sentence structure, but less influence on the topic, or what we call the aboutness of the sentence. Right. Should we always apply it? We started in tokenization saying we'll split on spaces. Everything is nice, straightforward, easy, and then I mentioned maybe 10 or 20 issues in doing that, right? Okay, I will not mention 10 or 20 issues, but there are some issues with just removing stop words. Something like this. If I have a phrase query, let it be, or to be or not to be. I think this is more common, right? You know this, what is to be or not to be? In one of the Shakespeare plays, right? This is a famous saying.
Yeah, and
If-
Hamlet.
In what? Hamlet, probably, yes.
Shakespeare's Hamlet, yeah.
Yeah, imagine that your system removes the stop words. What will happen to this? It will disappear completely. To be or not to be, all of these are stop words aslan. They will not be indexed at all. And whenever the user writes this query, what will the user get? Zero what? Zero matches, zero results. Will not get any results because they are not even in the index. Okay, completely removed. That's a side effect if you do that. Another example, which is different, the relational queries. Something like flights to Doha from London and flights from Doha to London. Now remove the stop words, what will happen? It will be flights Doha, London. So the results, if you do that also to the documents, what will you get? You will get both. You'll get some results from, some results to. You will be very happy. Right? Okay, so something like this is Important. If you remove, what is the solution? I told you. I don't have answers to all the questions today. But there is a solution, by the way, to this. What is the solution? The simplest solution. What is the simplest solution? Keep them, don't remove them. Imagine this is happening, by the way. Today, after the lecture, go home and write to be or not to be on Google. You will find it, right? What does that mean? It means it's indexed. It means that these two words are not removed. Yes, exactly. So that's the side effect of it, is that the index will be huge, but the search engine companies have resources, right? So that's not, if they can afford that, if they can do the processing efficiently, and if that will not affect the search results, which means that these terms will in most cases will get very low score, then that will not be a problem. طيب. Muhammad?
Yeah, so I thought like it's just going to like identify if it's a specific phrase in its data set instead of like keeping the stop words.
You can also. That would be similar to the issue of New York, right? To know that this is a phrase. Yes. But flights from, maybe flights from, and it will not generalize easily. There is no specific phrase here, ya Muhammad. Here there are phrases, but here they are not.
I'd argue there is. It's just normal, like a regular expression. We know that flights to, from, and like flights from to, regardless of what's in
the
between.
problem is that if you go this way, by listing what you know, there are many things that you might not expect, and you might miss. Okay, so again, what is preferred here are automated methods that will really go automatically and find these cases instead of just getting them manually from external resource, because they might not end. Question for you. Let's say that we've decided not to remove the word the. Of course, it's the most common word in English, right? We decided that we will not remove it. Will the word the, if I write it in a query, like not the Qatar University one, it will be odd. The mission. Maybe there's a movie like that. I don't know. The mission, okay? Or the city, or whatever, the something, okay? When the is actually not important. And maybe the mission is the name of a movie, it is important to get the there. But the research in Qatar, something like this, okay? Something that's really doesn't depend on the phrase. How can I from what we studied, do you see that the here will not really have a negative effect on the scoring, on the ranking function? Or it will? IDF will be very low. Very good. IDF will be very low, and thus the weight of that term will be very low. Although it will not be 0, but most probably it will be very low, because IDF will be very low. Why IDF will be very low? Because it appears in almost all the documents, right? So it will have even the largest, the smallest IDF. If it appeared in every document in the collection, what will be the IDF? 0 actually. Okay, and thus it's removed automatically. Okay. So in web search, with the search engines, the trend is to keep them actually, because they can afford that. They can afford that in indexing, and they can afford that also with efficient ways of query evaluation. So the common practice, although we just mentioned that in web search we keep them, the common practice is to remove them, okay? Assuming that we don't have the resources to keep them. And there are lists of common stop words. You'll find lists for different languages available. And you can also have your own special stop words. How can we do that? Given a collection, how can I know which words I can consider as stop words? Yeah, the frequency. The document frequency, actually. IDF depends on the document frequency, right? We don't need IDF to. We need just DF, and those that have very high DF can just be removed. You can consider them, maybe the top 100, 20, 200, whatever, can be considered stop words and will be. Of course, that might affect performance, retrieval performance. But sometimes we have to do that if we have limited resources. We cannot afford having very long posting lists in the index. It's not just this disk space, but also in scoring that will be very slow, because we'll have to traverse a very long posting list, right? Okay, step 3. Any questions so far? So what are the 2 steps that we covered so far? Tokenization and stopping or stop word removal. So which one is done first? Tokenization, then among the tokens that we will get, if any of them is in the stop list, then it should be removed. So after these 2 steps, we have a stream. So we started with string, one string, right? And then, which is the text that we will index. Then we got a stream of tokens. Then we got sorry, a node? Yes, stream of tokens that doesn't have stop words. But still it is stream of tokens now. Okay. The last step is called normalization. So the goal of normalization is to make words with different surface forms look the same. What do you mean by surface forms? The sequence of characters. Okay? How the sequence of characters is the surface form of the word. So, for example, if the document has "there are few cars" written this way, with all capitalization and everything, and the query has "car," should they be matched or not? They should be matched, right? So there must be a way to convert from this one to this one.
Sorry to bother you, doctor, but how is this any different than stemming?
We didn't talk about stemming yet. Stemming is part of normalization, actually, Muhammad.
I see.
Okay. Yes, stemming is a normalization step, of course. We'll get to it, inshallah. So it's not different. It's the same concept. But in normalization, we do more than stemming. So stemming can be just one step in normalization, but normalization can be also can include other steps. So anyway, in this example, we need to match car with cars written this way. So here is the big picture. We have a sentence or text. Do tokenization, we get tokens, and then do normalization, which is the process that will convert things like that, convert different surface forms to same form. And when we do that, we call what we get eventually terms. And this is what will be indexed. And this is what we call from the beginning the vocabulary that we have. And this is the dictionary of vocabulary. So the dictionary is not a list of words. They are not list of tokens. They are list of terms. Okay? These terms are not exactly the words that appear in the document. The document went through some of the stages, like what we are discussing, to get into terms. And remember that same process, same steps, in the same order, have to be done to both documents and queries, so that we can match. If we do it on one side only, we will not match them. Okay. Type. The first thing in normalization usually is done is case folding. If we have uppercase, we just lowercase everything, so that they can match. You know that A capital and A small are different strings, right? They have different encodings. They are not the same character. They are different characters. So if we want to match them, then we have to convert from uppercase to lowercase. So things like that will be done if we have car with all capital, car with first capital, car with last capital. All of them will be normalized. That's why we call this part of normalization. All of these will be normalized to car if we do case folding. Okay? Right. With everything that we discussed, seems like very nice, simple, straightforward idea. Of course, there are issues. So something like this: Windows, W capital, Windows, W small. Should we match these two? Yes. Capital W most probably means Windows as an operating system, not Windows as Windows in the house. Okay? Yes, but the problem is, if we do this blindly like that, then if you want to match Windows, the operating system, you will get documents about Windows in the house. No, this is the problem. Everything can match. The question is whether this is good or not in terms of relevance. If the user, the query has Windows capital, and you lowercase everything, it will match Windows in the house with the sense of Windows in the house. Okay, so that means that we also need to be careful when we do case folding. It's not straightforward just to lowercase everything. Okay. Yes. This is an issue that you need to think of. Okay, now if I want to deal with this specific case, how would I deal with it? Not quotations. How can I know which one in the document is the right one? Huh? Even without the context, with a simple rule. Exactly. That's the simple rule. If there is a capitalization that's not in the first word, keep it. But sometimes the first word also is Windows, the operating system, so it might not work all the time. Okay, so things like that can be also done. And also, don't forget that, as we see here, users are so lazy. Even if I'm looking for Windows, the operating system, I will write it small. مفيش فايدة. That shows you how hard search engines problems are. If you wrote Microsoft, then probably. But if you wrote Windows only, it might depend on the history of the user. Or, yeah. Huh? Profile.
Most users are looking for.
If I am a carpenter, and writing Windows, most probably I mean the Windows in the house. If I am a computer scientist, Yeah, so other words will add, but we are talking about decisions that have to be made. Not yes, all of them would be, but I mean made at what time? Which is done offline. You don't see the queries yet. Okay, so you have to make this decision. You cannot make change the decisions of preprocessing based on what you will see. Of course, if you have query logs, can help here. Okay. Type. How about this? I bought it from General Motors. So we talked about this, right? We can avoid something like this if we keep the whenever we seek first capital letter, we can keep them. Black versus black. If we lowercase everything, what is the first one? First one can be a person name. Okay? We destroyed it. It's now like a color. It's not a person name. So the issue here is that what do we want to keep in the index? If we didn't, for example, if we know that this is different from that, then we should keep both in the index. And it doesn't have to be just one of them. This is the point that I want to say here. Okay? Because these have two different meanings. The idea of equivalence classes also appear here. There are generally words that their surface forms are different, or they look different, but actually they refer to the same thing. Okay, like so forget about this for a moment. Like this one, USA with dots and USA without. PhD. Maybe if this is not an actual number, maybe they have the same meaning with the others. Something like multidisciplinary, or something like lowercase when we discussed about tokenization. So tokens that have different surface forms, but actually they have the same meaning, if we deal with them the same way, we call this equivalence class, because any one of these we want to match with any other. That's the general meaning of an equivalence class. Okay, equivalence class has different elements, has several elements, but any one of them is a representative of the entire class. What do we do with diacritics? Something like this. Or even closer to us, kutub and kataba. If we remove the diacritics, these are now the same word, although they are actually different, right? One means write, and the other books. They are somehow related, but they are not the same. Okay, so if we just remove the diacritics, then sometimes the meaning even will change or will be affected. So are you asking what happens with Quran? Especially in Quran, yes. If you will, this is special with Arabic in general. We tend now not to use the critics, but the language actually has this. Try. You never maybe tried it before. We don't write the critics usually. This is different. You mean it's not even related, يعني. Although write and books, they are not very related, but there's some relation. Because someone can write a book, but yes, of course, there are. When you change, if you have something in mind, I don't have something in mind now, but ممص مثلا, yes. Yeah, we will have so many examples like that. Yeah, so it's a catastrophe actually if we remove the diacritics in this way. But what happens is that for Arabic, most probably, and you can check by the way, you can try now. Go back after this lecture. I think you have many things to do. Try it on Google. How can you know what Google is doing? Write two different queries, or at least one query without the diacritics, and see what are the results. Will the results have both? Which means that it matches both. Try with the diacritics and see what happens. If it matches any, if you wrote the diacritics and it matches both ways, then it seems like they are removed. Okay, so that's another issue. So the idea of normalization is to actually create these equivalence classes. If we remove the diacritics, that means that we put these two words in one class as one thing, right? Whether it is kutub or kataba, it's the same word now. Although this is not correct, of course, but that's what happens if we do this removal of the diacritics or the accent in French. But the most important criteria, again, is to be consistent between documents and queries. Whatever you will do in documents, you'll have to do in queries, otherwise you will get a mismatch. And be guided by the common behavior of the user. Okay, and we know that Arabs, unfortunately, now don't write diacritics. So you have to deal with that. If the documents have diacritics, then if you keep them as they are, and the users will not write diacritics, what will happen? You will not match the documents, and you will lose them. But that doesn't mean that you should remove them also. Yeah, you should have something that will satisfy different users. Okay? But you can be guided with the behavior of the user. And if we don't know that the user almost never write diacritics, we wouldn't think of this as an issue, right? Because we know that diacritics in Arabic, for example, change the meaning. So the default thing is to keep them. But if we keep them, then they will not be matched. They will not appear in the search results. So we have to deal with that. Sometimes there is what we call asymmetric expansion. So we maintain relations between unnormalized tokens. So here we didn't do the normalization so that they will appear the same. We keep the different surface forms, but we also keep the relation between them. For example, in the example of windows, okay? So we might do something like this. If the query is window, so we'll keep windows with W capital separate from windows that with W small. Okay, so these will be two different terms in the index. Now, when we have a query with window or windows, whatever, both will be the same by stemming, but let's say window here, that is all small letters, we will search in both window and windows. Okay? But that's not the capital. Now we assume that if the input is not capitalized, then we'll not search in any capital terms. Okay? But if the word is, okay, let me explain this in a different way. There are three things here, not two. There is window without S. Okay? And there is windows with small w and windows with capital W. And you can think of this as three different things, by the way. Yani window without S, most probably, or maybe 99%, they are about the house, not the. Although I hear people sometimes say window, not windows, but anyway, it happens for the operating system. But most probably it is not, if you write it as a query at least. Okay, maybe they say it, but they don't write it that way, hopefully. Okay, so if the query is window without S, then that shouldn't go to Windows operating system. So it should go to either window or Windows that is small. Okay, if it's Windows with W small, then we don't know whether it is Windows the operating system or Windows the house. So we will search in these three terms. So this is like what here? Like expansion. When we see this, we will expand the query like synonyms that we see in the programming assignment. But synonyms is given by the user. Okay? Here it's done by the system. The system maintains the relationship so that it can be used when we get the query. Yes, if I consider the three of them, of course I will get results that have any of them. Now if I write Windows with W capital, then it's clear evidence that we mean the operating system. Okay, so we'll go to Windows only. That's a heuristic, of course. So this mapping can be maintained at the search engine and used whenever we have queries like this. Of course, it's less efficient because we have to do this expansion, but it's potentially more powerful because it will do more matching. We mentioned also the idea of thesaurus before, I think, which is something like a dictionary that tells us this word and this word are synonyms, or this word and this word are antonyms. Relations between words, explicit relations between words. So for example, so this is like hand-constructed equivalence classes that are given to us. So we know that car and automobile are the same thing, right? They are two different words, but they have the same meaning. They are synonyms. So we can explicitly encode that in the search engine. It's not scalable, but we can do it. Okay? Things like different spellings of the same word. One is American and the other is British, but they're actually the same meaning. Yes? It's just a mapping. You don't have to complicate it, okay? But it's just a mapping that says that this is an equivalence class, and this is an equivalence class. It might have more than one word, of course. I mean, more than two words. Synonyms. Right? Now, when you can use this while you are doing normalization. Whenever you see one of these, and for example, car and automobile, okay? Whenever you see one of them, what should you do? Yes, replace it with whatever you call the equivalence class. I can call it car-automobile. That's the term that will be indexed. Whenever I see car or automobile, I will write in the index. The index term will be the preprocessed, the term that will appear out of this document is car-automobile. But that, if I want to, if now I have the query, it will not match, right? The query has car only. We'll have to do it the same way also. Whenever I see car in the query, I will convert it into car-automobile so that it will match. Although, of course, the query doesn't have both, and the document also doesn't have both, but that's a way of matching these words together. Or we can expand the query. And when we get the query, that's another way of doing it. When we get the query that has car, we add automobile also to the query. This is query expansion now, so that it can match any of them, right? How about spelling mistakes? ها؟ او خلاص يعني هتتعمل من نفسها، ما احنا this is what we study, right? Okay, so how can we do them? One way is called soundex. If you think about spelling mistakes, of course you can compare the character sequence between pairs of words, but another nicer idea is to and this is an algorithm, by the way, it's called soundex, is to try to encode the word by how it is pronounced. Because most of the spelling mistakes are actually in characters that are vowels, okay, that will not affect pronunciation much, okay, and that unfortunately we will not study this, but it is called soundex. Actually, it converts every word to specific code that indicates how it is pronounced. And if I have two words that are not exactly the same, because one is maybe missing one character or two characters, or there's some misspelling, most probably you have the same soundex form, and thus they will match. Okay? So we can index with the soundex form to match them. This is very clear in spelling of foreign names. How many different forms Muhammad can be written in? Huh? M-A, M-U, M-O, لا M-A ما فيش M-A, sorry, M-O or M-U, double M, M-A-D or M-E-D, so many, right? So if we keep them as they are, they will not match each other, although we know that this is Muhammad, right? One way of matching them is by using soundex algorithm. Soundex will convert it into encoding that will capture the sound of the word, okay, and they will match. Search about soundex algorithm; it's really nice, and we don't have time to study it, but it is really nice. It is used in the Interpol, because in Interpol they try to match names that are written in different languages. Okay, so they want to match really names in really completely different language than the language of the source of the complaint or source of document. Okay, so if I am not if I am not a native English speaker, and or actually let's make it the opposite way. If you are an English native speaker and you want to write my name, let's say that my name is Muhammad, you will not write it probably the same way that I write it, and if I ask it, a third person will write it in a different way, and that's why we have different spellings of Muhammad, for example, right? So soundex algorithm tries to normalize all of these based on how the sound of each word is. Yes? Yes. So they try to see if this may make sense in another language or not, this sequence. Yeah. But that's not part of preprocessing. Yeah, it's to the query more. Yeah, it's trying to process the query, not the document. Okay. Okay, we still have the lemmatization and stemming. We'll try to cover them quickly. So lemmatization, again, we are still in normalization. Okay, lemmatization is a process that converts the word into its root, its linguistic root. Okay, so it implies doing proper reduction to the base or dictionary form. This base or dictionary form or linguistic root is called lemma. So for example, we convert am, are, is to be. That's the dictionary base for all of these three words. So whenever I see am or are or is, I will convert it to be. So the past tense converted to the present tense, see. Okay? Car, cars, cars, cars to car. Okay? So that needs what we call morphological analysis. That needs really linguistic knowledge to do it. It's not straightforward at all. Okay, and not everybody can do this. Can know the root of every word. So if we do that, for example, to this sentence, the boys' cars are different colors, then probably this will be converted or normalized to boy, and this to be, and colors to color. Okay? So this is what we call lemmatization. So converting each word to its linguistic root. But it needs linguistic knowledge. The easier step than that, which can be done more efficiently, is stemming, what we call stemming. So lemmatization is correct linguistic conversion. Stemming doesn't have to be linguistically correct. Okay, so it converts from a word or a token to what we call a stem, part of the token, by doing some removal, either the affixes or suffixes. Prefix or suffix. Part of the word in the beginning or part of the word at the end, based on some linguistic rules. But there are rules that are few rules, so that this algorithm is really efficient. But the side effect of that is that we will get terms that are not actual words. They are part of words. They are called stems. So let me give you so the idea, before giving you some examples, of course, eventually we will have all of these to be converted into play. So plays, played, playing, player. These are different surface forms of the same word, which is play, right? By adding some suffixes. So in stemming, we'll get rid of these suffixes so that all of them will be mapped to play. Something like plurals, different tenses, some of the suffixes that does some derivational process, and it converts, for example, from verbs to nouns. So we remove these so that we can get to something that is common between different surface forms. In most cases, this will not change the meaning or the aboutness of the word. In most cases, but of course, it's not all the cases. So we call the algorithms that do that stemmers. Okay, they convert words into stems. Remember, stems are not lemmas. Lemmas are linguistically correct root or dictionary base. Okay, but stems don't have to be linguistically correct. They will be just part of the word, but they might not be proper words. Here's an example. Okay. The words automate, automates, automatic, automation, all will be reduced to automate. This is not an English word, right? Do we care about this? Do we care about having terms that are English words? As long as they capture the same meaning, and as long as we will do the same with the query terms, they will match. That's why I don't know if you saw this or not in your code. If you see the query terms after preprocessing, you might figure out that they are different from the query terms, the query words that you see in the query file, because that's after preprocessing. Some of them are stemmed. Okay, so they are not original. They are not the original query terms. So here, if I have this this sentence, for example, compressed and compression are both accepted as equivalent to compress. That's an example, right? That's a sentence. If you do stemming using the English Porter stemmer, that's the most common English stemmer, it will be something like this. It will be, actually, we'll get this exactly. Look what happens. Example is example without E. That's not an English word, of course, right? But this is the stem. Compressed is compress. Compression is also compress, and that's good, right? Because I want to match compression with compressed with compress. R, assuming that it was not removed as a stop word, will be stemmed to AR only. Accepted will be accept. Equivalent will be equivalent. Okay. Probably also equivalence will be the same stem, will have the same stem, and so on. So stemming suggests crude affix chopping. Affix means either prefix or suffix, something either at the beginning of the word or at the end of the word they are removed, or sometimes they are removed and replaced by something else. Here are some of the most common algorithm for stemming English is called Porter stemmer. There are many implementations in different programming languages. So there are the stemmer actually is going through some rules and phases of reductions, and one of the conventions that are implemented in the stemmer is something like this. Of the rules in a compound command, select the one that applies to the longest suffix. And if I have a word and that word I can apply multiple rules on it, Porter stemmer will select the rule that will be applied to the longest suffix. What are examples of rules? So here we are talking about suffixes only, okay? At the end of the word. So whenever at the end of the word appears this suffix, SSES, this means that converted to SS only. So for example, processes will be process. Y to I. Why is that? Yes, but look at the example here. Reply will be a reply with I. Not exact. Yes? Yes, it will match replied. Okay, when you see replied, it will be reply with I also. So replied will be the same. Okay. IES will be converted to I. So replies even will be reply also with I. Okay. TIONAL to TION. So international will be intonation. Okay. We don't care about the meaning, by the way, here, as long as they will be the normalization will happen to two terms that are really have the same meaning. Of course, that's not guaranteed. Sometimes you will see that completely different words will have the same stem. Okay, and that will be problematic, of course. Okay, so nothing is perfect here. Here means that if I have more than one letter before EMENT converted to none, which means remove it. So replacement, because it has EMENT at the end with more than one character before, it will be replaced without anything after C. But cement, not more than one, it will be kept the same. Okay, I think we'll have to stop here because I have to leave. And inshallah, I think we have just a couple of slides. We'll finish it next time, inshallah. Any question before we leave? Yes, about the project. There's no time to discuss it, but inshallah, I will post a list of project ideas over the weekend. But what I want you to do as soon as possible is to form teams, form groups of 2 students, okay, and send it to me as soon as possible. Okay. I will, inshallah, post the ideas on the weekend, and then I will give you some time to select and write a quick proposal about it. I will send you, inshallah, the guidelines. Okay. We'll not have any lecture, of course, next week. Have a good break. Inshallah, we'll see you in 2 weeks.